In this video for section 1.4, we're going to talk about different categories of data. Our first categorization is quantitative or qualitative. And this is kind of tricky because the words look very similar, so you have to be very careful when reading questions. Quantitative data is data that is numerical. These are numbers with units. The units could be things like dollars, pounds, inches, percentages, or number of people, or number of products. Numbers with units. Qualitative data is data that comes in categories. So for example, if you were to ask someone about their marital status, they would respond with something like single, married, widowed, or divorced. And so those responses are all words. So qualitative data, your response to the question would be a word. Our next categorization is time series and cross-sectional. Time series data is data values that are observed at different points over time. So I'm measuring the same thing maybe once a day, once a week, or once a month. Cross-sectional data is when I take data measurements from different individuals at roughly the same point in time. Next, we have data measurement levels. There are 4 of them: nominal, ordinal, interval, and ratio. Nominal data are data in categories with no inherent order. So marital status is an example of this because single, married, divorced, none of those is inherently higher or lower than the other. They're all just categories. In ordinal data, you can rank or put the data in order. So for example, income ranges, you could ask someone if their income is from $0 to $20,000, $20,000 to $40,000, $40,000 to $60,000, or $60,000 or higher. And those are able to be put in order, and we know that $0 to $20,000, someone who chooses that is going to have less income than someone who chooses $20,000 to $40,000. Military ranks is another example of this. There's an inherent order in the ranking system. With interval data, we can measure the difference between 2 values and take an average. And temperature in Fahrenheit or Celsius is a good example of interval data because we can find the average temperature and we can find the difference between 2 temperatures. So we know the difference between 78 degrees and 80 degrees is 2 degrees. Now, there aren't actually very many examples of interval data because most numerical data falls into the ratio category. The ratio category, we can measure the difference between 2 values and take an average, just like with interval data, but the ratio category also has a 0 point, at which 0 means none. And so if you think about temperature in Fahrenheit or Celsius, 0 degrees doesn't mean that there is no temperature, it just means that it's a cold temperature. So 0 doesn't mean none for temperature, which is why it's considered to be interval and not ratio. Things like weight, distance, money, and time, the value of 0 means none. 0 means no distance, $0 means no money, 0 seconds means no time. And so those are considered to be ratio. And like I said, most numerical data types will fall into the ratio category. So next we're going to look at example 1.1. It says to determine the type and level for each factor, and this is shown in a spreadsheet in the textbook in figure 110. So these are our factors right here. We're first going to categorize them as quantitative or qualitative. So I'm going to start with qualitative. College name would be qualitative data because those are words. So would state, because state names are also words. Michigan, Texas, Florida, those are all words. Public or private. Now in the textbook, what they show in the spreadsheet is that they're coding public or private with 1 or 2. So those are numbers entered in the spreadsheet. However, the numbers themselves do not have units. So 1 or 2, there's no unit attached to that. So that would actually be considered qualitative, even though there are numbers in the spreadsheet. The rest of the data is all quantitative. So we have SAT scores, number of applications, anything with number of in front is probably going to be quantitative. And then we have in-state tuition, out-of-state tuition, percentage of faculty with a PhD, so dollar amounts, percentages, those are all quantitative, and student-faculty ratio would also be considered quantitative. So now let's look at whether this data is time series or cross-sectional. Since we're taking data from different universities, all at about the same point in time, they would be considered to be cross-sectional. If I was measuring data from these universities over time, so for example, I could keep track of the tuition prices for each semester over a number of years, then that would be considered time series, but that's not what we have here. And then lastly, we're going to look at our data measurement levels: nominal, ordinal, interval, or ratio. So the nominal data types that we have here, college name would be nominal. There's no inherent order in that. None of the college names are better than the others. State would be nominal. And public or private would be nominal. None is inherently better or higher than the other. Even though they're coded with the numbers 1 and 2, there's no reason that private has 2 and public has 1. I could easily just switch those numbers around. So that would also be considered nominal. The rest of them would be considered ratio. So in terms of number of students could be 0. Tuition could be $0. I mean, not practically, but technically it could be. Percentage of faculty with PhD, that could be 0. Student-faculty ratio could be 0 if there were no students. Again, it doesn't have to practically be able to be 0, but just to have a value of 0 makes sense. I was a little bit curious about the SAT scores, since I didn't think that you could have an SAT score of 0, but I looked it up, and in fact, if you don't answer any questions, then your SAT score will be 0, and so that would also be considered a ratio type.